Okay, so this is our equation. So you have x squared, and taking from the palette, we have the second order derivative of y with respect to x plus x times the first order derivative of y with respect to x plus 8 times x squared times y, and again in Maple for y. Okay, if y is the dependent variable, you want to include in parentheses the independent variable. Okay, so for this equation, okay, we have set equal to 0. And if we look at what we have for the solution in y, so if I go to the palette on the far right hand side, okay, so solve dE y of x, and this is what we have for the solution, and this one is inclusive of the first and second kind, but I'm interested in only the first kind. And if we look at what we have in this particular case, so looking at evaluating at a point, and what I want to do is eliminate the presence of the second kind. And notice we have the coefficient c of 2, and I'm just going to set this equal to 0. And right now I'm starting out with y of 1, which is going to be at 10.7, but just taking what we have for x equal to 1 and eliminating the presence of the BESSEL of the second kind, and we have this particular statement. Now we had that y of 1 is equal to 10.7, and now I want to specify, okay, just what the first constant is going to be. So if I copy what I have here and set equal to 10.7, and I'm looking at solving for c of 1, okay, so you have 10.7 all over what I have for the BESSEL of the first kind, and approximating, and we'll say to 10 decimal places, so we have c of 1, we have at negative 54.43960.167. So for what I'm going to have here, if I'm looking at evaluating y of 1.7 and y of 2.3, what I can do in this particular case is I can copy this value, and I'm multiplying by the BESSEL of the first kind, so taking what I have in the general solution, and if I look at evaluating at a particular point, and this time I'm looking at x at 1.7, and if I take what I have here and approximate, that's going to be 12.953. And if I go back and look at evaluating what I have for y at 2.3, so going back to what I had in this particular case, all right, so going back to this input, evaluating at a point, and we have with x at 2.3 and approximating, and this is going to be the result in this particular case. Okay, for the next equation, okay, so this time we have alongside y of x, instead of the constant 8, we have the quantity of x squared minus 8. And if I'm looking at solving for the differential equation in Maple, so we have for y of x, again I'm interested in just the BESSEL of the first kind, and so looking at what we have at this stage and putting in terms of where x is equal to 1, and we have evaluating at a point, so I'm going to set x equal to 1, and to eliminate the BESSEL function of the second kind, so I'm going to set c of 2 equal to 0, and so I have this particular expression. And again, we have given that y of 1 is equal to 10.7. So if I'm looking at solving for c of 1 in this equation and setting what I have from y of 1 and equal to 10.7, and solving, isolating the expression for c of 1, so I have this ratio, and if I isolate, or I should say approximate, so we have a big number here with 394.26 almost, And if I take this number, okay, representing the constant, and going back to the general solution and multiplying C of 1 numerical approximation by the BESSEL function of the first kind for what we have, again, attaining from the general solution, and for what we have in evaluating. Okay, so this time we have x at 1.7, and so we have at 42.277. And if I go back, okay, say we have with x at 2.3, so just copying this step and evaluating at a point, and again we have with x at 2.3, and so we have about 84.18. Okay, for the third equation, okay, so we're back to a constant alongside x squared y, and if we're looking at solving for the differential equation in terms of y, okay, and again I'm interested in just the BESSEL function of the first kind, and so going to evaluating at a point, and we have the given condition for x equal to 1, and again I just want to eliminate the BESSEL function of the second kind. Okay, so we have in this particular case, all right, now for 0, 7, okay, now the 0 is going to be in reference to the 0 order, and looking at what we have in terms of solving for C of 1, okay, and again we had the condition that y of 1, okay, was equal to 10.7, and looking at solving for C of 1, and say approximately have 35.657, and if I just copy this and multiply by the BESSEL of the first kind, okay, now we have evaluating at a point, and this time we have it x at 1.7, okay, so have 0.893, and looking at what we have and re-entering this command, and this time evaluating, whereupon we have that x is at 2.3, and this time we have negative 6.526. Okay, so looking at what we have with the coefficient of the y term at the end with the binomial x squared minus 16, so if I solve for y of x, okay, and I'm interested in just the BESSEL function of the first kind, and the 4 indicates the order, and looking at eliminating the presence of the BESSEL of the second kind, so I'm going to set C of 2 equal to 0, and I have the initial condition given whenever x is equal to 1, and if I look at solving for C of 1, that we have y of 1 is equal to 10.7, and solving for C of 1, okay, and approximating, so I have this fairly large number, and carrying over what we have here for, so we got C of 1 with this value, and if I multiply by the BESSEL from what we had in the general solution, and carrying out, okay, to what I have with x at 1.7, okay, so this will come out to 81.18 roughly. And if I go back to this command, and this time evaluating where we have that x is going to be at 2.3, and so this is going to end up being the output in this case. Okay, so all in all, we have for the first equation, we have in the general solution limiting it just for the first kind of order p, and in the general solution, so we have from the first equation, we have y of x is going to be equal to the BESSEL function of the first kind, where the order is going to be 0, and we have 2 times the square root of 2 times x, or 2x times the square root of 2, and on the basis that y of 1 is equal to 10.7, we end up with y of 1.7 at about 12.95, and y of 2.3 is negative 14.2 roughly. And for the second equation, now we have in terms of a Bessel function of the first kind, the order is going to be 2 square root of 2, and so we have the general solution at j sub 2 square root of 2 of x. And on the basis that y of 1 is equal to 10.7, we have y of 1.7 at about 42.28, and y of 2.3 is about 84.2. And for what we have in the third equation, so we're back to a zero order Bessel function of the first kind, and here we have j sub 0 of 7x, and y of 1.7 again is just under 0.9, and y of 2.3 we have just under negative 6.5. And for what we have in the case of the last equation, so we have a fourth order Bessel function of the first kind, and so we end up with j sub 4 of x as the general solution, and we have a y of 1 at 10.7, we have y of 1.7 at almost 81.2, and y of 2.3 at almost 240.2.